Today we are going to be looking at the law of total probability. So this law follows from the previous laws we've discussed when we discussed the multiplication law. We also look at the theory or the formula for conditional probability. So today we are going to be looking at law of total probability. So this more like relates everything we've been discussing together, more like we are moving away completely from the set theory that we discussed earlier into core probability. So what I'm going to do, I'm going to state this law, explain it, and then we apply it to use it to solve some problem. Remember to subscribe if you've not subscribed to my channel so that you get updates when I make new lessons. So click on this subscribe button below to subscribe. If you have any math problem, any math homework or assignment in school or quiz, just let me know if you need help and I'm going to respond to you. Alright, so let's see. I'm going to state this law, then we explain it. It says that let B1, B2, all the way to Bn be such that summation of B1 to Bn be equal to the sample space or the whole or collection of all the events. So the sample space collection of B1 to Bn be all the events available to us. Bi is not equal to Bi intersection Bj equal to 0. It means that all these events Bi, B1, B2, B3, they are disjoint. They are not related. They are not having anything in common. And for all I is not equal to j, with probability of Bi is greater than 0, it means that probability of Bi is not equal to 0, meaning that these events are not empty sets or empty events. They have likelihood of occurring. For any event A, probability of A is equal to summation of conditional probability of A given Bi, summation of all the conditional probability of A given Bi times the unconditional probability of Bi. Explanation goes this way. The events Bi are mutually disjoint, and the union is the sample space. Then to find the probability of an event A, we take the sum of all the conditional probabilities of A given Bi, taking over the whole of Bi, right? So if you have two events, the first event and the second event, and event A, another third event, depends on the first event and the second event. Therefore, the complete probability of A is the conditional probability of A based on the first event and the conditional plus the conditional probability of A based on the second event. So you are summing all the conditional probabilities of A. Let's now take an example this time using the same previous lesson we discussed about a bag containing balls. You can review it in the previous lesson if you want. Now a bag contains 3 red balls and 1 blue ball. 2 balls are selected without replacements. What is the probability that the second ball selected is red? Alright, what I'm going to do first, let's go to the screen, to the board, and then we state this law and then we continue from there. Also, form a habit of writing all these things by yourself using a pen and a paper. So, probability of A is equal to summation from I is equal to 1 to n of all the conditional probability of A given Bi times the unconditional probability of the individual event Bi. Alright, so now we can apply this law in the case of the bag containing balls, red balls and blue balls. To find the probability that the second ball is red, we need to sum 2 probabilities. The probability that the second ball is red given that the first ball is red, and the probability that the second ball is red given that the first ball is blue, right? So you see how it plays out. In the first instance, it could be that the first ball is red. It can also be that the first ball is blue. So we need to sum the probability that the second ball is red given that the first ball is red, and the probability that the second ball is red, given that the first ball is blue. So let's write it out in the notation form. So we have that probability that of R1 is probability that the first ball is red, right? And probability of B1 is the probability that the first ball is blue, right? What is the probability that the first ball is red? Now we have 3 red, 1 blue. Total of 4. Probability that the first ball is red is simply 3/4. Probability that the first ball is blue is 1/4. So now we want to find the probability that the second ball is red. And that is probability that the second ball is red, R2. And we are saying that we need to sum the probability that the first ball is red, the conditional probability that the second ball is red, given that the first ball is red, and probability that the second ball is red, given that the first ball is blue. So now the probability that the conditional probabilities, let's say, this probability that the first ball is red, that the second ball is red, given that the first ball is blue, right? Given that the first ball is red, okay, let's start from that way. Times R1. Sorry, I think I mixed up something, so let's take back this. Okay. Times the probability of R1 plus the conditional probability of R2 given R1 times the unconditional probability of R1. So unconditional probability of B1. Yeah. So in this case, we are summing conditional probability of that the second ball is red, given that the first ball is red, plus the conditional probability that the second ball is red, given that the first ball is blue. So B1. All right. So now the conditional probability that the second ball is red, given that the first ball is R1, right? So let's see. So this conditional probability that the second ball is red, given that the first ball is red, it means that, let's just write it, P R2 given R1. It means that the first ball is red, and we've actually removed one ball. Yeah, we've actually removed one red ball, so we only have 2 red balls over what? Over 3 blue balls. Then the probability that the second ball is red, given that the first ball is blue, the second ball is red, given that the first ball is blue. So when the first ball is blue, is 1/4, and we've removed 1 blue ball, remaining only 3 red balls. So this probability is going to be 3/3, which is 1. That will enable us to now calculate this total probability that gives us, this case will give us 2/3 times probability of the first ball being red is 3/4, plus, in this case we have R2B1 1 times probability that the first ball is blue. The first ball is blue is 1/4. Good. So this is going to give us 1/2 plus this is going to give us 1/4, and this will be equivalent to 3/4. So this is fairly easy, I think so. So you see how we played around with the probabilities, and this actually is a simple case. What I recommend you do, write it out neatly with a pen and a paper, and then it's going to become clearer as we go. Let's see if we can take another example. Okay, so I'll basically allow you to play around with this, but maybe I can give you an assignment. Calculate the probability of B2. So calculate the probability that the second ball is blue. So this assignment, leave the answer in the comment box below, and then the next tutorial we now look at this example 2 and see how it goes. I'd like to thank you for viewing. Remember to subscribe and also like this video if it has been informative for you.